Okay, here we go. We are going to try this, and I hope it goes well. We're going to do some boards go up, please, on limits. We're going to do it digitally, and hopefully I can improve this as we go along. I, we're going to start reviewing for the AP test at this point, and I think that the best thing that you can do to learn math and to remember math is to just do math. So I'm going to try and maintain that, and I'm going to try and help you along the way too, like I would if we were actually in a school right now and not all hiding from a virus. Speaking of the virus, I hope that you, your friends, your family, everyone is is well and healthy. Please talk to me if you have some kind of issue that's going to stop you from being able to do everything that we're doing here, and I can try to work with you as best as I can. So, our first problem will be, and I'll say it out loud anyway, the limit as x goes to 5 of fraction bar top x squared minus 25 bottom 2x minus 10. So the way this is going to work is I give you a problem like this, and then you hit pause and you do it. And then I'll give you a little bit of time to do that, to hit pause, and then I'll show the answer and go through it. Your choice as to whether you listen to me as I go through it or if you go on to the next problem. It's fine if you get it right. If you're like, okay, I'm good, I don't need to hear him, go on to the next problem. If you want to listen to me just to hear me talk through it because that helps you learn it and remember it, then that's fine too. Your choice. Okay, so you can pause now. All right, here we go. I'm going to show you the answer. Okay, so I want to point out a couple things here. I think there are a couple different ways that you could do this. There are two obvious ways. Hopefully you got 5. That's the correct answer. One way would be to factor. That's how you learned in pre-calculus. What do? This is difference of two squares. You can factor a 2 out. I cancel my x minus 5s. That's my whole, right? That leaves me with this guy, x plus 5, bottom 2. And then I can plug 5 into that. 5 here gives me 10 over 2, gives me 5. Or, now that we know calculus, we can use Hopital's rule. In most cases, I would prefer to use Hopital's rule because it works like everywhere that any of the old pre-calculus, well, it works, I should say it again. Most cases is correct. There are some, and I'll show you some exceptions in a little bit. But most cases, it works faster. It also works in all kinds of different cases, and you do the same thing. All you do is take a derivative. With factor cancel, say I gave you a square root. Like, that's a different technique than this thing. Anyway, let's do it. If I hop this, right? If I hop this, I take the derivative of the top and the derivative of the bottom individually. I'm not doing quotient rule. What's the derivative of the top? Well, that's 2x. It's power rule. What's the derivative of the bottom? Well, the 10 goes away, and the 2x gives me a 2. So I get 10 over 2, and that's 5. One thing I want you to notice, the Hopital's rule here is a lot faster, a lot less work than this. Here's our next problem. Limit as x goes to 1, fraction bar top, x cubed minus x, bottom, x minus 1. So this is one for which I think that Hopital's rule is definitely going to work. Well, maybe I'm wrong. No, you could do it either way. I would prefer to do Hopital's rule. Anyway, hit pause. All right, I'm going to go on. Boom. If I hop this, I get the limit as x goes to 1 of this gives me 3x squared minus 1. That's what I have here. And then this derives to 1. And from there, I can plug in 1. You don't have to show all this work. I'm just doing this so you can all see it. I plug in 1 to this guy for x. That gives me 3 times 1 squared minus 1. Well, 3 times 1 squared is 3. Minus 1 gives me my 2. over the 1, so my answer is 2. Hopefully you got that one right. Okay, next problem. I've changed the way I'm doing this with this app here. All right, so limit as x goes to 9 of fraction bar top, root x minus 3, bottom x minus 6. So hit pause. All right, I'm going to show the answer. Hopefully you've hit pause already. You've paused it already and you've done it. So boom. This one's a little deceptive, and this is what the AP likes to do to us. Usually you're like, oh, maybe I'll hop it here, right? Well, you know, with these other ones, this, if I plugged in 1, I got 1 minus 1, that was 0. And 1 minus 1, that was 0. The previous one, if I plugged in 5, I got 25 minus 25, that's 0. Over 10 minus 10, that's 0. All of these had 0 over 0. And that's why I could hop them. This one, if I plug in 9, I get root 9, which is 3, and then take the 3 away, I get 0. But in the bottom, I don't get a 0. If I plug in 9 here, I get 9 minus 6, that's 3. So this is not hoppable. If you hopped it, you kind of like fell into a trap that was set for you. So, make sure that you can hop it, or you can use limit techniques, or it's worth it before you go and do a bunch of work. Because this one, I can just plug in the value. I get 0 over 3. What's that? It's 0. Okay, next one. Limit as x goes to 3 from the right. That means that's what this little plus sign up here means. Fraction bar, top, 2 minus x, bottom, x minus 3. I'd like you to try it. Hit pause. Give it a shot. Okay, here comes the answer. Ooh. Okay, so limit as x goes to 3. This one, like the previous one, I had a 0 just in the top but not in the bottom. This one, I get a 0 in the denominator of the fraction but not in the top. So I have a number over 0. Well, you should know graphically that that gives us a vertical asymptote. There are all kinds of ways that I can have a vertical asymptote. I could have them both go up. I could have them both go down. I could have one go up, one go up, one go down. I could have them go the other way, right? So the best way to do this is to test a value. Here, I'm going to test 3.1. You may say, why are you testing 3.1? Well, this is limit as x goes to 3 from the right. So if I were to draw a little number line, 0, 1, 2, 3, and go just a little bit to the right, well, 3.1 would be there. So I'll take that. If this was a negative, then I would go a little bit to the left. And that would be, yes, you guessed it, 2.9. So I test 3.1 and I figure out what side of the curve this, or what side of the x-axis this curve is going to be on. This isn't a fail-proof method, but it'll work most of the time. So I test 3.1. That gives me 2 minus 3.1. All I care about is that is a negative number. And in the bottom, I get 3.1 minus 3. Well, this is bigger than the 3, so I get a positive number. So when I test 3.1, I get a negative over a positive. Well, that is a negative, which tells me that we are on the downside of one of these. So therefore, this graph is going to go to negative infinity. So what's the limit as x goes to 3 from the right? Well, it goes down, down, down. So I get negative infinity. Hopefully that's cool. Some of this is like way back pre-calc. So that's why we're reviewing, because it's going to be on the AP test, and I want you to be good with it. And I know you are good at it. So here we go. Next one. Okay, so limit as x goes to infinity, fraction bar top, 3x squared minus 2x, bottom, 8x squared plus 4. So, again, pause the video. Okay, hopefully you've paused it and done the problem because I'm going to slide over to the answer right now. Whoop. This one, there's no work to do. When I was saying earlier that Hopital's rule is always easier, I could use Hopital's rule here. I would hop it twice. The first hop would get rid of this. The second hop would get rid of that. And I would have some stuff over here, and then they would all cancel eventually. I might hop it 3 times, honestly. But this is a rule from pre-calc, or even Algebra 2 for you. So if I've got a polynomial like this, a polynomial over another polynomial, it's called a rational function, and I want to look at the infinite limit, it's the same as the horizontal asymptote. So all you got to figure out is where the horizontal asymptote would be. Well, in this case, remember, you would take this coefficient and divide it by this coefficient because x squared was the biggest piece in the top one and the bottom one, and those guys compete equally. These guys don't matter, so I just divide the 3 by the 8. So we get 3/8. Hopefully you're good with that. You're remembering. I know you can. Okay, here's the next one. Same deal. You are going to try it. You're going to hit pause. You're going to try it. I'm going to show you the answer soon. Okay, hopefully you've done it. Here it comes. This one's just 0. You may say, wait a second. I thought it was 8 over 7 because x to the 4th's here, right? So we just divide. Well, I tried to trap you again. This is something that the AP will do as well. They're like, oh, we're going to make it so that they think it's 8 over 7, right? But look at this. I got an x to the 4th and an x cubed. This is the biggest term of this one. Here I got an x to the 4th, but I have an x to the 12th. Well, this one, even though it's not in the front, is the bigger term because it's got a higher exponent than this, right? So what do? I've got, this is going to infinity. This is going to infinity. This guy's going way faster, right? So I think about the top, it goes to a number over a big number over a bigger number, right? So it's like something over a bigger infinity. Well, what happens then? Think about like 300, which is a pretty big number, over 8 million, right? That's a big number, well, a moderately big number, over a way bigger number. What's that do? It goes to 0. The bottom wins in this case is the easiest way to think about it, so therefore the limit goes to 0. What would happen if the top won? Okay, this is the last problem of this board work session. So here we go. You try it by hitting pause. Okay, here comes the answer. It's infinity. You may say, what? Well, you might have said what from the beginning because this is not a polynomial, right? But look, this is an exponential function. This is a polynomial. You should know from pre-calc that exponential functions always beat polynomials. So this grows way faster. I mean, exponential growth is the talk of the town right now, right? If it was polynomial growth, it would not be as bad. This exponential growth is going to win, right? So the top beats the bottom. So I get a big number. I'll do it the same way. I get a big number in the bottom, and I get a bigger number in the top, like 3 million over 800, right? What wins? The 3 million. So as our inputs get bigger and bigger and bigger, go to infinity, the top wins, so I get an infinity. So hopefully this worked well for you. I'd like to know how it worked. So, we use Google Classroom. Feel free to leave a little comment in Google Classroom. Tell me if this worked well for you. If it didn't, I'm going to try to do this. Sometimes these things take a lot of effort to put together. This one was pretty simple, and I want to try to figure out how to make them really simple because I'm limited with my time, just like you all are probably limited with your time. I'd like to try to keep doing this. Because I want to maintain as much of the regular classroom as I can, or as much of the feel of the regular classroom as I can, and I think it also helps. So you'll have some stuff to do. It'll be written on Google Classroom, and good luck. And I hope you are all doing very well.